Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, reorganize the array. So what the problem is saying is we'll be given an array of elements with indices ranging from 0 to r of size -1. Our task is to write a program that rearranges the element of the array such that r of I equal to I. If an element I is not present in the array, -1 should be placed at the corresponding index. Okay. So what the problem is trying to say, tell is basically, let's say there's an array. Okay. Now, we want to place the elements such that r of I equal to I. Okay. So for example, here 0, 1, 2. Okay. So what the problem is saying is this zero should be placed at the zeroth location itself. This one should be placed at first location itself, and this two should be placed at the second location itself. Okay. So this is the expectation. The array should be sorted in this way. Okay. And if you see, the expected time complexity is O of n and the expected space complexity is O of 1. Okay. Okay, now how can we solve this problem? Okay, so if we see the first naive approach, okay, which will take O of n, okay, which will take O of n. So simply what we can do is we will iterate through this given array, okay, and we will, for example, right? So if we come across this, if we start iterating this array, so we'll see, okay, if it is 2, then we are going to have an, for example, let's say 0, 1, and 2. We're going to have an answer array. Okay. So what we'll do is answer of 2. We'll say, okay, what is this element? Answer of r of I, for example, right? Answer of r of I equal to r of I, will say. Okay, equal to r of I, will say. So answer of r of I is what? 2, right? So answer of 2 equal to r of I is again 2. So 2 will place here, right? 2 will place here. Then we'll go to the next element. Okay, so we'll again say answer of r of 0. So what is r of 0? R of 0 is 0. So answer of 0 equal to 0, basically. So we'll place here. Then simply answer of 1, again r of 1 is 1, right? R of 1 is 1. So answer of 1 equal to r of I, which is 1. Okay, so we'll place here. So in this way, the answer in this way will get our resultant output. Okay, but here you can see we are taking extra space, right? We are taking extra space, which will take us O of n extra space. But here the expected space is what? O of 1. Okay, so we have to think something better. Okay, now since the problem is saying is that the elements will be in the range from 0 to r of size -1 only. Okay, so for example, if there are, the array size is 3. Okay, the array size is 3. So the elements are going to be, the element will start from 0. Okay, can be started from 0, and it will be array of size -1, that is 2, right? So considering this property, considering this condition, okay, we can definitely solve this problem in O of n space time complexity and O of 1 space complexity. Okay, so let's see how we can solve this problem. Okay, so let's take an example of the first example. This example we'll take. Okay, -1, -1, 6, 1, 9, 3, 2, -1, 4, and -1. Okay, so what we are going to do is we are going to start with this particular, we'll start iteration, right? We'll start iterating this array. Okay, and we are going to run a while loop, for example, while I is less than n. Okay, and n is nothing but the size of the array, and I is the index. Let's say it is started from 0. Okay, and what we're going to do is we are going to take an element here, the first element, for example, correct, right? Let's say correct. We have to place the element at the correct position, right? So let's say correct we took. So r of I we took. Okay, I is nothing but 0. Okay. So now what do we want to check? If now again, there can be -1 as well. So in that case, what we want to do? So for example, if a particular element is not present in the array, -1 should be placed at the corresponding index. So what in this case, for example, if there's -1, so simply we are going to ignore this element and we are going to move ahead. Okay, so we are going to check if correct is not equal to -1. Okay, and then we'll see the other condition. Okay, and then we'll see the other condition. Then we are simply going to move ahead. Okay, we are going to, if correct is not equal, if correct is equal to -1, then we are simply going to move ahead. Again, here also it is -1. Okay, so we will ignore and we'll move ahead. So here, for example, we have come here now at the 6th, right? So correct basically holds 6. Correct holds 6 now. Okay, correct holds 6. Now what we are going to check? This we are going to check if this is already placed at the right location. Okay, so when can we check that? So for example, array of get I. Okay, okay, so we will only Okay, so if for example, here minus one, and it was 2 year, right? It was 2 year, not 6. It was 2 years. So okay, so this two is already placed at the correct position, 0, 1, and 2, right? Two is currently placed at the correct position 2. So this okay. So we need to go ahead. We need to ignore this because this is already moved placed at the right position. Okay, but here in this case, 6 is not placed at the correct position. Six is at what? At second position, right? Which is not the right. So here we're going to check if arr of get I is not equal to arr of get correct. Okay. Okay. So here arr of get I is what? Arr of get I is what? It is it is 6, right? And arr of get correct. Correct is what? Correct is 6 basically. And arr of get 6. 6 is what? 0, 2, 3, 4, 5, and 6. So at sixth position, 2 is placed. Okay, at sixth position, 2 is placed, right? So we what check we are making here. Okay, if you want to, so we want to what check we are making here is we want to place the element at the right position. Okay, we want to place the element at the right position. Okay, okay. So here, okay, so here that is why we are making this condition. Okay, so here it is not placed at the right. This 6 is not placed at the right position. So what we are going to do is, first of all, so since now we have stored correct. Correct holds 6, right? Correct holds 6. So first of all, we will whatever element is there at the sixth position, we will move it to this particular position. Okay, this particular position, that is sixth position. For example, so what are we going to do? Arr of I, okay, arr of I equal to arr of correct. Okay, arr of correct. So arr of correct holds what? It holds 2. And okay, so what we are doing is we are placing this 2 at this particular position. Okay, okay. And finally, what we are going to do? Arr of correct. Okay, correct is what? 6, right? Correct. Equal to correct. So what we're doing is we are placing the sixth element at the sixth position. At the sixth position. That's what we are doing. So what we're doing, we are placing this 6, right? This 6 at this particular position, at the right place, right? At the right place. So these two statements. So what we're doing, okay, step 1, we are storing the value in the temp variable. Temp variable in this case is nothing but correct. Step 2 is, so we'll move this element, whatever was there at the current position, right? At the current I position. Okay. At the current I, and third is place the temp, whatever is the value at the right position, that is correct. Okay. So these are the 3 steps. Okay. So here, what we're going to do, what we have done is we have placed 6, and here we have placed 2. Okay. Now we won't increment I in this case because we also want to place this, whatever is the element, right, at the correct position. Okay, I hope you're getting it. I hope you're getting it. Okay. So we also want to place this 2 which we have placed here, right, at the correct position. Okay. So here, that is why we are not going to increment I here. Okay. So again, this will come to this for while loop. Okay. We'll take arr of I. Arr of I is nothing but correct. Okay. Arr of I is nothing but 2 now, right? 2. 2 is placed here. So here we are going to check is 2 not correctly placed at the second position. Is to not correctly placed at the second position. No, it is not the case, right? This we are checking. This we are checking. Is 2 placed at the correct position? Yes, it is placed at the correct position. So simply we'll go ahead. Okay. So okay. So I think let's do one thing. Let's take this example here, minus 1, 6. Now what do we have? 2, right? 2. Then we have 1, then 9, then 3, then 6 here, right? We have placed 6 correctly. Okay, we have placed 6 correctly. Then we have minus 1, 4, and minus 1. Okay, so we were here and we checked 0, 1, 2. We checked whether this is placed right. Yes, it is placed right. Let's move ahead. Okay, so we are moving ahead now. So what we're going to do here now, 1, we have come across 1. So correct holds will hold 1. Okay, now we are going to check. We are going to check whether this 1 is placed rightly or not. No, it is not placed rightly. 1 needs to be at one location only. Okay, currently it is situated at third location. Okay, at third index. So that is not right. So what we're going to do is we have stored this element, right? This element in one variable, in one temporary variable. Okay, now whatever is at the first position, at the right position of 1, okay, we will move that element to this location. Okay, we'll move this element to this location, so it will be -1 here. Okay, and what this one, right? We will place it here at the right location. So this array will look like what? -1, 1, 2, right? 2, -1 here, 9, 3, 6, -1, 4, and -1, right? Okay, so our I is was here, it will stay here because we may need to move this element again at the right position, right? At the right position. But since it is -1, okay, we will go ahead. But since it is -1, we'll go ahead. Okay, so 9. So now we have come across 9, right? So we'll check. So if 9 is correctly placed or not currently. So it is placed at what index? 2, 3, 4. So it is placed at fourth index, which is not right, right? It needs to be go at here at this location. So first of all, what are you going to do? We'll store 9 in the correct variable. Okay, we did that. Okay, we check that. Is it placed correctly? No, it is placed at fourth location. Okay, so first of all, what we're going to do is whatever is the element, we are going to store at this particular location. Okay, so this will hold what? -1, right? And the third step will be to store 9 at the ninth location. Okay, we won't increment I again. I will be placed here. Okay, I will be placed still here, and we'll check whether this needs to be placed at the right location or not. So this is called cyclic sorting basically. Okay, so here since it is -1, we'll simply ignore it. We won't enter it in -1. Okay, so we will go ahead. So now 3, right? We have come across 3. Now correct will hold 3. We'll check whether it is rightly placed. No, it is placed at fifth index currently. Okay, so it needs to be placed at its right location. Okay, its right location. So what we're going to do? So first of all, we will, whatever is the third position, right? Whatever is at the third position, we will move to this particular location, to 3's location. Okay, so it will be -1 now. It will be -1 now, and we will place, then finally we'll place a 3 over here at the right position. Okay, so again our I will still be here because we may need to place at the right location. Okay, so here if it is -1, so we'll move ahead. Okay, and here we'll check. We have come across 6 now. We'll check. Okay, 6 is at 6 only. It is at right position. So let's go ahead. We'll come here, right? We'll come here. Now -1, again it is -1. We'll simply go to ignore it. We'll move ahead. We have come across 4. We'll check. What is the 4 located at, right? It is located at 8. Okay, so it is not rightly placed. So we'll correct holds now 4. Okay, now whatever is at this position, right? Whatever is at this position. So we'll simply move ahead. We'll move to this one. So -1, it will come here. And finally, we'll place 4 over here. So in this way, using cyclic sorting, we are able to achieve whatever is expected in O of n time complexity and O of 1 space complexity. So I think I hope you've got the intuition. I think let's go to the code. You'll understand better. Okay, you'll understand better. So let's go to the code. So int, for example, what are we going to do? First of all, int. So first I'll show you the Java code followed by C++. Int n equal to arr.size, right? Then int I equal to 0. Then what are we going to do? While we are going to run a while loop till I less than n. Okay. Then we'll place a correct variable arr of get I will take. Okay. Now let's dry run through this simple example. Okay. Let's take this example. 2, 0, 1, right? 2, 0, 1. So 2 is based here, right? So now currently we are at 2. Okay. So correct holds 2. Okay. Now what are we going to do? While correct is not equal to -1. If it is -1, simply ignore it. Okay. Not while, it won't come while, sorry. It will be if only. Okay. And then arr of get I. Okay, arr of get I, and then arr dot get correct. They should, I mean, we are checking here if the correct element, if it is not stored at the right position, at the correct index, right? Then we need to place it at the correct index. So for in this case, so what we are checking here is arr of get I. So we took this arr of get at 2 and arr of get correct. So correct what holds what? Correct, for example, it holds 2, the element, right? So we're checking arr of get correct. Get correct is gives us what? 2 get correct, right? So this is 1. So these are not equal, right? This is not equal. So we are going to swap, basically. We're going to swap the elements. Okay. So first of all, what are you going to do? So arr dot set. First of all, we are going to move this particular element 1. at this particular location. Okay, at this particular location. So arr of get or set, right? Arr dot set I, comma arr, or maybe we'll say correct. Oh no, sorry. Arr dot get correct. So this what we are doing with this statement, we are placing this one at this particular location. So now the array looks something like this. 101. Okay, 101. We have placed this one at this particular location. 101. Okay. Now then the next statement will be arr dot set correct. Okay, correct. We are saying. So this correct is what? This correct is what? It is an index basically. So what we are saying is correct is index, right? So correct. So arr of 2, this particular 2, okay, at this particular position, we are placing 2 at this particular position, right? We are placing correct at the correct location. Okay. So arr dot set correct, comma correct. Okay. So in this way, we are placing at the right approach, right problem. Okay. Now again, for example, now here we are not incrementing I. We are not incrementing I, right? I is still same. I is 0. So again, what we're going to do, this our array, the I is still here. We have not incremented I. Okay. So again, we are going to follow the same process. So we are going to check if this is rightly placed. No, it is not placed rightly, right? So we will move it. We'll move ahead. 0, 1, and 2. It will be, right? I will still be here, right? I will still be here now. Since it may be the case that this particular element is not still correctly placed, but it is not the case here. So 0 is correctly placed at 0th location, right? So here. So what we're going to do here? So here, for example, add dot get 0, right? Sorry, it should be not equal to, right? It should be not equal to. So if we see here add dot get 0, it gives us 0, and add dot get correct, correct is nothing but 0. So add of get 0, it is again 0. So in this case, simply what we are going to do, we are going to increment I. Okay, we're going to move ahead. Okay, and in this way we are going to take care, or we are going to solve this problem. Okay. Okay, so finally what we're going to do, we are going to return the same array. Okay, so let's compile this. It may be a bit complex to understand this, okay, but it is an interesting problem. So I hope you've got the solution. The test cases are being processed. Thanks for watching. Please subscribe to my channel, like the video. Okay, the test cases are being processed. Yes, thanks for watching. Let's quickly see the C++ code here. So in C++ code, I don't know why they have given constant vector. Okay, constant. Okay, because of this, since this is constant, we are not able to modify or swap the elements, right, in the array. Okay, because of this, we have to take an extra space. We have taken a cloned here, right, and we have run the same cyclic sorting algorithm here. So here we have done the same, right? So cloned is nothing but the clone of array, and we are checking here if if the correct element is not placed at the right position, then we are swapping. Else, if it is placed at right position, or if it is -1, then we are simply incrementing I, and then finally we are retaining clone. Okay. Thanks for watching. Please subscribe to my channel, like the video, because a lot of efforts goes into solving the problems and making the video. Okay. Thank you so much. Have a happy, healthy, and a great day. Thank you.